Alright, Brian, I'm going to walk you through kind of a quick start, quick setup guide for the robot and the mill and the robot-mill interface. So I've got two computers set up here. One of them is the mill control computer. The other one is the computer that is used to program the robot. Here's the robot's controller. Once you've programmed the robot, you can download that program to the controller and disconnect the programming computer, and this will work as a standalone. I'll just go over the connections really quickly. There are two front panel connections. One of these, this guy here, goes to the computer used to program the robot. The other connection goes to this teach pendant here. On the back, there are two connections that go to the robot itself. This one and that one. Here they are, both going to the actual robot. And then there are two connections, a DB9 and a DB15 connection that go out to the breakout box. And lastly, coming from the breakout box, we have a set of wires that goes to the solenoid that actuates the robot's gripper, and another two wires that just go to this 12-volt solenoid that you can set up with an air vise, similar solenoid. Okay, when you make these connections, make sure that the robot's controller is off. We'll just go through starting up the robot's control software here.
Let me,
Great.
I got a real...
Power cycle this thing here. And try again. Oh, that's why I got a bunch of these open. Here we go. One more time. So, let's get the software open. You can type start communications, and calibrate. It actually gets you some motion of the robot. It goes through a calibration procedure. Note that all the commands in this robot language are in all caps. So for instance, to go to the home position, it's just all caps home. Robot moved to its home position. Alright, let's talk about the breakout box for a second. I've been using terminology that assumes that we're looking at this box from the perspective of the mill. So there are 4 outs from the mill, and they are relays 1, 2, 3, and 4. Relay 1 is hooked up to the robot's controller software, so the robot sees this relay as an in, but I'm going to call it an out because I'm looking at it from the perspective of the mill. So relay 1 is goes to the robot's controller. Relay 2 goes to the solenoid that controls the air vise. Relays 3 and 4 aren't used right now, but you're welcome to hook stuff up to them. There's 12-volt supply inside this breakout box that you can steal if you want to hook up other solenoids or any other device. And on the other side here, we've got what I'm calling ins. They are inputs from the perspective of the mill controller. Of course, there are outputs if you're thinking as the robot. Ins 1, 2, 3, and 4. In 1 is how the robot communicates back to the mill. So it's actually a robot output, but it's on input 1. And then inputs 2, 3, and 4 don't have anything connected to them right now, with the exception of I've got switches on the front that can kind of fake out the inputs or outputs of any of these. So you'll notice I haven't told the robot to say anything, but if I flip this switch I can turn on input 1 or input 2. Likewise with the relays I can short the relay here, so that's basically closing the relay. The mill talks to the breakout box with M codes. Turning on the relays is with M501, and then it takes a P word corresponding to which relay you want. So we can turn on the mill by calling M501, or excuse me, turn on relay 1 by calling M501P1. When I hit enter, you'll see the light corresponding to relay 1 goes up, and we can see the robot will see that on its PB6 input. So here it is, it's saying PB6 256, but if we go back here and we turn that relay off, relay is now off, robot PB6 bit question mark different value. I think I might have mixed up the syntax of the first value. There you go, switch PB6 bit question mark. There you go. So it goes from 0 to 64 depending on that M code, or in the case of my second test I just flipped that switch to fake it out. The robot can communicate back to the mill. The robot's outputs, or the mill's inputs, are on port PA on the robot, so you could say PA1 on, and you can see that input 1 on the mill lit up. I'll go PA1 off. Input 1 on the mill is now off. And M508 can be used to wait for one of those inputs to come high. So M508P1 pauses all execution of any codes. You can see waiting for response there. That will pause execution of any code in G code until this input goes high. And that input goes high when the robot's program says PA1 on. So turn the input 1 on, and we see that the mill no longer says that it's waiting for anything. So those are the basics. Typically, what I've done for